Here we will see infrastructure layer in clean architecture. Infrastructure layer handles interaction with external tools and systems. It contains concrete implementation of abstractions defined in domain and application layers, which isolates the core business logic from database, messaging and API concerns. The infrastructure layer decides how the application will interact with external resources. The domain and application layer defines what should happen and the infrastructure layer defines how it happens. Primary responsibility of infrastructure layer is to provide concrete implementations for the abstractions defined in core layers, that is domain and application layers, bridging the business logic with external frameworks, database and third-party services without disturbing the core code with technical details. Some of the responsibilities are data persistence. It implements repository interfaces defined in the application layer, which includes configuring ORMs like Entity Framework Core, managing database context and handling migrations. Then external API integrations. It contains clients and wrappers to communicate with third-party web APIs, REST or gRPC services or payment gateways. Then cloud and storage services. It manages interactions with cloud providers for file uploads, block storage or serverless functions. Then messaging and events. It handles the setup and communication with message brokers like RabbitMQ or Kafka for event-driven architectures. Then cross-cutting concerns. It provides concrete implementation for system-wide technical operations like logging, caching and system time clocks, and authentication and security. It interacts with identity providers and handles OAuth or JWT mechanisms. Structural building blocks of infrastructure layers are persistence, which is responsible for database interaction. Main components are database connection, entity configurations, migrations and database access. Then repository implementations. Application layer defines the interfaces and repository encapsulates data access logic. For example, framework implementation, data mapping, etc. Database context. It commonly implemented using Entity Framework Core. Main responsibilities are database connection, change tracking, CRUD operations and transactions. Then database context. It is commonly implemented using Entity Framework Core. Main responsibilities are database connection, change tracking, CRUD operations and transactions. Then external service implementations. It handles communication with third-party systems. Then authentication and security components. It is responsible for security related implementations. For example, JWT token generations, identity providers, OpenID Connect, etc. Then messaging components. It is used in distributed systems. Main responsibilities are publish event, consume event and message routing. Then caching components. It is used to improve performance. Main responsibilities are to store frequently accessed data, reduce database calls, etc. Then logging components. It is responsible for application logging. Main responsibilities are error logs, audit logs and performance logs. Then file storage components. It is responsible for file management. For example, local storage, Azure Blob Storage, Amazon S3, Google Cloud Storage, etc. Then configuration. It manages external system settings, database connections and framework integration while hiding these details from core business logic. And dependency registrations. It must follow the inward dependency rule for implementation of interfaces defined in core layers, that is domain and application. Benefits of infrastructure layers are complete decoupling. By hiding technical implementations behind abstractions, your business logic remains pure and focused entirely on what the system does, not how it is technically executed. Then simplified testing. Since external frameworks and databases are isolated, you can easily mock dependencies to write fast, straightforward unit tests for your core business logic. Then easy technology swaps. If a third-party service provider changes or a library become outdated, you only modify the adapter in the infrastructure layer. The core domain and application rules are untouched. And better organization. It separates technical concerns into dedicated logical modules. Drawbacks of infrastructure layers are high bipolarity and mapping. Because domain entities cannot reference infrastructure model, developers must map between domain models and database entities, which creates extra classes and increases maintenance overhead. Over-engineering risk. In smaller applications, enforcing strict boundaries and adding interfaces for external services introduces unnecessary navigation complexity. Then indirection and debugging. Abstracting database queries and external APIs behind interfaces This makes it harder to trace the exact execution path and debug issues. And pass-through layers. Strict adherence to layering rules can result in developers creating empty pass-through wrapper classes just to satisfy the architecture, which wastes time.